trig identities, which can be somewhat difficult to prove sometimes. The whole point of this is that we've already shown it to us, but we've got to prove that the left side is equal to our right side here. Now, looking at it, it probably makes sense that we'll work with whatever's on our left side here. Because there's so much, it'll be easier if we simplify and try to bring it down to this rather than trying to decompose this one the other way. So we got two fractional values with denominators that are different. Okay. What I'm going to do is I'm going to get a common denominator here. And there's a trick sometimes when it comes to like factoring with trig identities that we can show you, and sometimes when we're multiplying them too. So to get the same denominator, we need to think of it like, if it was 5 and 2, 1 over 5, 1 over 2, we had to add them. Well, we'd multiply by each other's denominators, both the top and the bottom of them. That way we'd have 10, right? The denominator is the same. So we're going to do the same thing here. I'm going to take the denominator on the bottom, and I'm going to have to multiply it by the top and the bottom of this. And I'm going to take the denominator on the bottom of this and multiply it by the top and the bottom of this. Okay? So I'm going to rewrite this whole thing out. I'm going to have sine squared x plus cos squared x. And we're going to be multiplying that by 1 minus cos x. Okay? Over 1 plus cos x. And I should put this in brackets. Think of it like that. It's going to be in brackets. 1 over cos x times 1 minus cos x. Okay, so that's just the first set. And then all of that is added to 1 times 1 plus cos x, just fits in there, divided by 1 minus cos x times 1 plus cos x. So this is where things can start to become pretty confusing. We're going to have to use like FOIL, distributive property, and we're going to start multiplying, sines times cos and sines, and there's probably going to be a bunch of factoring. If you're okay with that, that's great, and just keep working it out this way. One way to make things simpler, and you can write let statements, but you don't really have to if you're only writing to yourself. You can kind of say like let sine x, maybe just equal s, and let cos, because they're the only ones we're working with, right? Cos x equal c. And now I have like s squared plus c squared, which is something a lot simpler to look at rather than a ton of letters. We're going to do that. If it's not helpful, we'll just kind of go back to where we were. But that kind of helps us when it comes to factoring things. At least I find that. So, and you're gonna see it, I know, because you've already gone through it. So we're going to change this sine squared x. We're going to change it to s squared plus c squared. A lot simpler to look at. Okay, yeah. This becomes 1 minus c, easier to look at. On the bottom, before I actually carry it all out, I know that you already found
Can I see that?
Yeah, plus c, 1 minus c, okay. And then here we'll have 1 times, so I don't really need to write that 1 times. I'm just going to write what's on top. 1 plus c all over 1 minus c times 1 plus c. So in terms of factoring and foiling, this might be much simpler to look at rather than sines and squareds and coses and all those funny things. Now on the bottom, this is going to FOIL out. And when you FOIL this, this is like the result of a difference of squares. I'll do it on the side quickly on the left here. But when we FOIL this, 1 plus c times 1 minus c, well, we do 1 times 1 is 1. 1 times negative c is negative c. C times 1 is positive c, and c times negative c is minus c squared. These c's cancel out, and you're 1 minus c squared. So this is where we would call the difference of squares, but when we FOIL it, we end up at that.
Yeah.
Okay? So on the bottom now, I'm not going to do with anything on the top. Sorry, I shouldn't put an equal sign there, because it's technically just the left side. But we're having like the result, or the beginning, the standard form of the difference of squares. So the top is still left with s squared plus c squared, 1 minus c. Now the downside of this, when we have it in this version, it can be hard to actually apply the identities. But it's sometimes much easier for the factoring of stuff. On the bottom, we just said it's going to be 1 minus c squared, okay? And then we also know that this is going to be 1 minus c squared. So we're going to have plus 1 plus c over 1 minus c squared. Okay, well, this can be, and we'll put this all together. The denominator is the same, so we have technically s squared plus c squared, 1 minus c plus 1 plus c. And all of that is over our 1 minus c squared. Now, we might want to FOIL these all out. We'll see if that's going to be helpful. I might want to start applying trig identities, so it might be helpful to kind of go back to my sines and coses here, just so it's a little easier. I know that this is a Pythagorean identity here on the bottom. And I don't know if you can see it yet or not, but that's going to be the idea of 1 minus cos squared x. And 1 minus cos squared x is
sine.
Yeah, it's right where it becomes our sine squared x. So our bottom, without actually doing any interchanging, that can just be sine squared on the bottom here. Right?
Perfect.
So we have that. And if we look up, that's what they have at the bottom, sine squared x, even though we only have that. So now the last thing is how can we make the top of this the number 2?
Put 2. You just put a 2 and say you did it.
Yeah, we can just put a 2. I did this in my head. We might have to FOIL this out. We have squareds, cos squared. I don't know if FOILing it out is going to be that helpful. We can try it and see if it works. We'll FOIL it out, and then we'll turn everything back into sine and cos again. So when we FOIL, we do that by that, and c squared by both of them also. So we're going to end up with s squared minus s squared c, okay? And then we'll have, plus c squared minus c cubed. Okay, is that right? C squared minus c cubed, and then all of that is plus 1 plus c. Okay, so let's see what we can we're going to put everything back into its normal form now, because that's a little tough for me to make trig identities out of. So I have sine squared x minus sine squared x times cos x plus cos squared x minus cos cubed x. That one's going to be tough to work with. Let's see what we can do there all over this. Now, I don't know if the FOILing of this was going to be helpful to us or not. And this is sine squared x. We took a look at this. What kind of factoring can we do to this? Now, I wonder if back in this method it would have been nicer to look at. Let's take a moment and think about it for a second. Really hard for us by FOILing when you guys just pointed out that this is a Pythagorean identity. It's equal to 1. So let's just kind of work with our top again. We're going to go back to, I'll highlight it in blue. Let's actually get rid of this, what we had, because this is garbage. It's not helping us at all. Let's go back to that. We'll write them out again. So that's sine squared x plus cos squared x times 1 minus cos x plus 1 plus cos x. It'll disappear on my computer. Okay, so like you guys pointed out, obviously this is a Pythagorean. I shouldn't say obviously, I didn't see it.
Oh.
That's 1, okay? And we know that 1 times anything is just going to be that anything, right? So this essentially you could say cancels out. So we're now left with on top. We know the bottom is already okay, so I'm just going to focus on the top here. I'll highlight in yellow. I'm just going to look at this stuff because that became, this became the number 1, and it doesn't change anything, so we don't really need it anymore. So we have 1 minus cos x, and because it's just as addition, all the brackets drop off. So plus 1 minus cos x. Well, our negative cos x, oh, sorry, that one's a positive, good. Our negative cos x and our positive cos x
cancel,
eliminate each other, and you're left with 1 plus 1 on top, so not equal sign. 1 plus 1 over sine squared x is equal to 2 over sine squared.
Wait, 1? Wait, so this equals 1?
Yeah, sine squared x plus cos squared x. That is this Pythagorean identity way up here.
But then,
right? That's that. So it's equal to 1. So we can replace it with the number 1. So when I replaced it with the number 1, think of it like this. We did 1 times 1 minus cos
okay,
x, and the 1 didn't do anything. So we just left with 4.
That makes sense.
Okay. Good.